All right, this video is going to be on properties of logarithms. And like we said before, logarithms and exponential functions are inverses of each other. And so for us to learn the properties of logs, it's going to be helpful for us to go back and look at some exponential rules that we've done in the past. Because what we're learning today will be the opposite of those things. So one exponential rule that you should be fairly familiar with is if we did x squared times x to the 7th, we would say that we can multiply these together because the bases are the same. This x and that x are the same, so I can say that my answer is going to have a base of x. And then we would just add the exponents together. 2 plus 7 is 9. So when we are working on exponential rules, multiplying to us really meant to add the exponents together. That's something that we've learned in the past. Another exponential rule that you guys have worked with in the past is you've done division problems, like x to the 15th divided by x to the 5th. And here, if you did this problem, you would say 15 minus 5 is 10. So we would keep that base of x, and then we would subtract the exponents. So when we saw a division problem, that really meant for us to subtract. And then the last rule that is going to be important to us, this is not, there were more than 3 rules, but only really 3 of them are the ones that we're actually going to look at specifically. If you had an exponent raised to an exponent, you knew that you needed to multiply those together. This gave you x to the 6th. And the reason that worked was because x to the 3rd squared really meant that you had x to the 3rd times x to the 3rd. You had 2 sets of x to the 3rd. And so that's what made it x to the 6th. So these 3 rules are the ones that are going to be the most similar to the properties of logs that we're going to learn today. So here are our properties. First, we're going to look at log of 6 plus log of 3. So here, it's going to be the opposite, basically. Up here, multiply meant to add. Down here, add means to multiply. So we're going to write log once. So this is the same as the bases are the same, so we just write the base one time. So we're kind of condensing things down. So here, log is the same, log and log. And then we multiply these two together. 6 times 3 is 18. So for us now, we're going to say that add means to multiply. All right, second, let's say we have log of 6 minus log of 3. If divide meant to subtract before, then subtract means to divide. So 6 divided by 3 is 2, so this would be log of 2. So subtract means to divide. And then last, we're going to say we have 2 log 6, that's actually going to be log of 6 squared. And the reason for that is because we have 2 log 6 would be log 6 plus another log 6. So this 2 really means that you have 2 sets of log 6. And log 6 plus log 6, we know that add really means multiply, so that'd be 6 times 6, which is 6 squared. So these 3 rules are the same as the 3 properties that we use for logarithms. So we have 2 different forms of the properties that show up. One is the condensed form. So these right here, the log of 6 squared, log 2, log 18, those are all considered to be the condensed form. And that's going to be a single logarithm. And then over here, this form, the 2 log 6, the log 6 minus log 3, the log 6 plus log 3, is going to be the expanded form. And that's going to typically be multiple logarithms. Not always, like this one you can see is just one, but oftentimes it's going to be multiple logs. All right. Now we're going to write a note to ourselves. ln is log base e, right? That's something that we learned before, that ln was log base e. So the properties work for ln as well. So ln is log base e, so the properties work for ln as well. All right, so we're going to, and using our properties, we're going to be doing some expanding of logarithms, we're going to be doing some condensing of logarithms, and today all we're going to focus on is the condensing part. So we're going to look at how to take multiple logarithms and bring them down to one, and how to recognize what the different properties are that are present there. And then after we master that today, then tomorrow we'll go back and we'll look at expanding them. So for all of the examples that we're about to do, we're going to condense the log. That's going to be our instructions. So our first example is going to be log base 2 of 5. Plus log base 2 of x. So here we are adding the logarithms together. We can look and see that these two logs have the same base, right? Log base 2, kind of like up here how we would make sure that both of these were x's. If it was x squared times y to the 7th, I would not try to do anything with that. So here our bases are the same, so I know my answer is going to have a log base 2. And then to condense it down, I know that plus means multiply, so 5 times x would be 5x. And that would be my final answer for that one. Let's say I had ln 3 minus 2 ln x. So this one, again, my bases are the same. These are both ln's, and so I know my answer is going to have an ln in it. This is a subtraction problem, so I know that I'm going to be dividing these two things. And so it's 3 divided by, and then on this one I have to consider what 2 ln x means. If you guys recall, the number in the front really becomes the exponent to the x. And that's because 2 ln x's means ln x. I'm going to put this in parentheses. It means it's ln x plus ln x. And so that's ln of x squared, right? So I'm going to say x squared right there. So 3 ln of x squared. And the reason it was on the bottom of the fraction is, again, because this is a subtraction problem, and it means that those two things should be divided. Next, we're going to say log base 5 of 6 minus log base 5 of x plus log base 5 of y. So here, again, I'm noticing that all of these have the same base. So I've got log base 5. And first I have a subtraction problem, so I'm going to say 6, and then we've got minus x would be 6 divided by x. And then this part says plus, so that means that this is going to be multiplied. So I'm multiplying this by y. And most of us would not write the problem like that. Most of us would write this together and would say this is log base 5 of 6y over x. All right, for our next example, we're going to say ln of 3 plus ln of 5x plus 2. So you'll notice this is not the same type of plus as in I'm saying, oh, these things need to be multiplied together. The reason I know that is because I don't see another ln. I'm not saying ln of 5x and ln of 2. I'm saying that this ln is of this whole group of things right here. right? So when I do this problem, I'm going to say my final answer is going to have 1 ln in it, and these two things are being multiplied together. So the 3 is being multiplied by the 5x plus 2. And I can actually go ahead and multiply those things. So my final answer for this one should be ln. 3 times 5x is 15x. 3 times 2 is 6. So it should be ln of 15x plus 6. So similarly, let's say we had 2 log base 3 of x plus 1 minus log base 3 of x plus 1. So we know our answer is going to have log base 3, just one of them. And this is a minus problem, so we know that we're dividing things. The 2 in the front means that there's 2 of these. So the top would be x plus 1 squared. The bottom would just be x plus 1. And then we can go ahead and simplify that, because I know the top is x plus 1 times x plus 1, and the bottom is just a plain old x plus 1. And so I know that this factor on the bottom can cancel out with one of those x plus 1s on the top. And so my final answer for this one would be log base 3 of x plus 1.